these couple of equations that we're going to go through next, they're kind of like little puzzles, so I really enjoy these. Remember that you got a logarithmic equation, and we're going to usually start with writing our log equation in exponential form. And that's what I'm going to start with here. So I'm going to go to the logarithm that is furthest on the outside and find its base. That would be a base 2. 2 to the negative 1 is equal to log base 3 of x. Well, 2 to the negative 1 is 1/2. 1/2 is equal to log base 3 of x. Now we're going to write in exponential form again. So we exponential form once, and then exponential form a second time. So 3 to the 1/2 is equal to x. And 3 to the 1/2 is the same thing as the square root of 3. So x is equal to the square root of 3. The square root of 3 is positive. I'm going to check to make sure that if I have a variable in the argument, which I do, that solution keeps the argument positive. And in this case it does. There's no extraneous solutions. We've got x equals the square root of 3. Okay, let's try another that's kind of like a puzzle. Here we have 7 raised to the log base 7 of 2x, and that's equal to 7. Well, look at this. We have the same base. Let's set the exponents equal to each other. So I'll have log base 7 of 2x equals 1. Now we're going to write in exponential form. 7 raised to the first power is equal to 2x. We're going to divide both sides by 2, and x equals 7 over 2. Now, x does happen to be in the argument, and if I put 7 over 2 in for x, I'm going to keep that argument positive. Therefore, 7 over 2 is not extraneous. It is a solution. Here's one more problem that is kind of like a puzzle. See if you can try this one. Now, don't let the 3 natural logs frighten you or become daunting. Remember what I said here. I had 2 logarithms, a log of a log, and I started with the outsidemost logarithm. I had 2 logs, right? The log of a log, and I had to write in exponential form twice. Go ahead and try this one. How many times are you going to have to rewrite this equation in exponential form? If you're thinking 3 times, because I have a log of a log of a log, I've got a natural log of itself 3 times, you're correct. We're going to have to write this in exponential form 3 times. So go ahead and press pause, see if you can do this. Meanwhile, come on back and I'll be working away. Okay, if you're coming on back and you think you've got an answer, fantastic. If you need a little bit of help, I'm going to rewrite the first natural log as log base e. That just helps me see the logarithm a little bit better. Okay, so I've got e raised to the first power is equal to the argument of the natural log of x. Now I've got this natural log, which is a log base e, so its base is e. So I'm going to take e raised to the e power, so this is exponential form now a second time. E raised to the e power is equal to the natural log of x. So that's this. We've now written in exponential form 2 times, and we've got our third time right now. Natural log is a log base e. We're going to take e, raise it to the e to the e power. So we've got e raised to the e raised to the e power is equal to x. So in our calculator, this looks a little strange. X is equal to e upper caret e upper caret e. So it's a little strange. If we put that into our calculator, e raised to the e power of raised to the e power, we're going to have something like 2.718 raised to the 2.718 raised to the 2.718. So maybe that looks a little bit better, you know, a little bit more comforting to you. I'm just going to make it look like it's a whole bunch of smaller sized e's because that looks kind of cool right there. But that's our answer. E raised to the e raised to the e. E raised to the e raised to the e. So e raised to the e raised to the e. Cool stuff. That's the value of x. That's the value of x. Okay, next few problems we're going to talk about maybe taking the natural log of both sides. Taking the natural log of both sides is a technique that's important to know in algebra. And then also being able to solve different types of log equations where sometimes we're writing them in exponential form and sometimes we're able to just compare the arguments.